All right. So what am I going to talk about today? Obviously, we've heard about AI. Anyone here who has not heard about AI? Good. The- so we're seeing a lot of cool stuff happening with AI, a lot of demos and advanced voice doing cool stuff. But how does that actually integrate with software? What are the products to release with AI? And this is what I'm hoping you'll get a sense of changes the game. So let me take you through that, and hopefully by the end of it, you'll figure out that software is going to change forever, and with it, you as well. So a little bit about me. I've been to Wix for about 6 years. I'm in the data science group for about a year. Before that, some of you may know me as the head of document management. So yes, I'm kind of switching between roles. I'm a manager most of my career. Right now, I've started kind of a data scientist, so now I'm managing a small team. And our team does a couple of things. First of all, we're doing the research for the agent platform. I'm going to talk about it a little more further on. And we're doing a bunch of research that's actually about the building model. Very, very smart guys working with me. It's a lot of fun. But before I got to Wix, I got to do some other things that have to do with AI. Before that, we didn't actually call it AI. It was machine learning, ML. At CA Technologies, we had a mechanism for automatically detecting patterns of permissions and grouping them into roles. At Sales Predict, we've created models that predict which lead in the sales pipeline is going to convert at a higher likelihood. And at eBay, I was responsible for building the product catalog. Basically, we took all the products that came, or all the listings that came into eBay, and figured out which two listings actually belong to the same product and build the product out of it. So the point is, AI was already there. It didn't start in 2022, but there are some fundamental differences that I want to take you through. The main one is that in the past, we used to have data scientists that build the models, their own way of working, their own way of thinking. And we've had engineers who are likely like all of you guys. We did have a very small group of people which we called ML engineers. ML engineers are those that kind of understand enough of both worlds and are good enough engineers to build the tools for the data scientists to actually be able to run things and eventually get them to production. But when I managed these groups, I managed two completely different types of personas, and there was almost no mix between them. A little bit about the agent platform that we're building today. Obviously, I can't talk about myself without talking about that. This is one of the projects that came out of the innovation that started at the time that AI basically exploded. We're working very, very closely with the AI assistant company led by Guy Sofer. Love you guys, you're awesome. We're primarily doing the research. These guys are mostly doing the product. Obviously, we're kind of mixing here and there. But most of the time that you'll see me and my teams, it's in association with this product. All right, so I kind of give you a tip of things changed. Let's see why and what. There's going to be a lecture by Meir later on. He's going to talk to you about transformers. In a nutshell, I'm not going to talk about the science. The key thing that changed is generative AI, and I'm mostly going to refer to LLMs, which are basically, theoretically, stupid machines that get a bunch of text and they predict the next token in that text. What people have figured out, especially at OpenAI, is that if you take this architecture and make it like really, really, really big, then all of a sudden amazing things happen. Because in order to predict the next token, you need to understand the world. And all of a sudden, this mechanism started figuring out things that, for me, someone who worked with AI or ML before that, I needed to pick up my jaw from the floor. If the first time that you see someone say, I need a React component that does something, and boom, it's just rendered, it's mind-blowing. Today it becomes kind of obvious, but something really, really big happened at about 2022. And this whole thing is about the transformer architecture. I encourage you to go to that talk. So let's accumulate some of the things that happened. First of all, OpenAI released ChatGPT. That was the first public manifestation of AI. I would consider that to be kind of the iPhone moment. Because when Steve Jobs stood on the stage and showed the iPhone, I already had a BlackBerry in my pocket. So a smartphone existed, but something happened there that made it very accessible to the public. And with that, the explosion of that technology happened. Same thing with ChatGPT. But more and more models came out. The new topics started becoming the bread and butter of what we think about, like conversational assistants, prompts, agents. And I remember myself and other peers at that time were in an euphoria. In one hand, in depression from the other, because we're kind of saying, okay, this is the end game. We're not going to be needed anymore. All problems in the world have kind of solved. And it took some time to figure out that this is not actually it. But it was the beginning of the hype, which is the continuation of everything that we have today. The biggest change that affects us as engineers is this thing. Before the technology that came out through OpenAI, building AI or machine learning was a completely different process. As I said, we used to have data scientists building models through a very dedicated machine that takes a very long time, and they build it to do something very, very specific. You deploy it to production, and it's a tremendously difficult process, especially if you're doing something with large amounts of data. All of a sudden, we got to a point that, hey, I have a REST call that I can just do a curl and send out a request and get a response. And that response can be a JSON. And overnight, all engineers that can basically work with REST had AI at the tip of their fingers. They can start thinking of ideas that before that would require assembling teams, gathering data, and doing very, very complex science on very, very difficult machine. And the distance from, I have an idea, to, wow, it actually works, is about 5 minutes. And I think this is the biggest thing that affects us and the products that we're building. This obviously led to a lot of innovation at Wix. Some of the projects that started at that time, one of them I talked about. I think the agent platform is one of these topics. Some of them Aviran mentioned, like Astranova, the user of user-facing chatbot, and many more, which I'm not going to mention because obviously I'm going to miss some. But I think Wix management understood the opportunity and gave a lot of leeway for these ideas to come into fruition. As I said, I'm a head of company. Just taking me and shifting me to AI is not something that a lot of companies will do, and I think it goes a long way to show that Wix management is fully on board with pushing AI. We've had the hackathon, many very good ideas that came to fruition. Many of those became ideas in the products later on, and I see Ayal with Igor kind of smiling in the background. Hi, Ayal. And of course, at that point of time, I've joined the data science group. As I said, data scientists have kind of had their cheese moved. So things have changed. If before that, data scientists were responsible for building the models, now the sudden the engineers are just running ahead and building whatever they want and making, stupid mistakes. And I think it became the responsibility of the data science group to help other teams at Wix and show them how this is done, because a lot of the principles that apply when you just call an API call and get a response from an AI, this is still not software as we're used to. The principles around how to do data science still apply to that kind of software as well, even though you're not actually building a model. And I think this was a big gap that I needed to figure out as I went along, because obviously I've started making API calls and doing a lot of cool stuff from day one. And hopefully in this lecture, I'm going to give you a few hints about what those differences are. My first attempt was with a project in the editor. I was still in document management at that time. And we've done something called template injection. Basically, the idea was to take a template and let the user kind of describe his own business, and then replace all the texts in that site to match his business rather than the generic text of the template. Now, it sounds easy because AI can very quickly generate content, but it needed to take into account the design of the website. It needed to take the content and break it down into multiple components. It needed to adhere to the general logic of what that template is supposed to do. So there are a lot of nice tricks in that system that I'm not going to talk about. But it basically started, hey, I have a cool idea, let's test it. And it literally took me a couple of hours to try something in the interface of ChatGPT, and I got back JSONs that looked like it's the solution. Then I said, great, but I can also code. So I started coding, and 2 days later, I actually had that as an API call in document management. So I could literally go to a website, type in a command in the text of that website, and I've actually seen the components change. Awesome, it worked, right? No, it was as far away from working as can possibly be imagined. And then we got to agents. So everything that I've talked about before, where things kind of became more complex, and I've learned that things are hard by just doing a simple prompt, just got multiplied by 100. As soon as you get to agents, more considerations fall into picture, and I'm not going to talk about all of those. But I think the key principle that is the real substantial difference is that when it comes to agent, you don't determine the flow. Normally, when you do software, you do A, B, C. If not this, then do that, blah, blah, blah. The flow is very deterministic. When it comes to an agent, you tell it, what's the next thing that should happen? And something decides it. And you don't know what it's going to decide in advance. And you don't know why it's going to decide that. And then pretty much all principles of software engineering that I knew went out to the window, and I had to learn everything from scratch. So let me take you through some of that learning. Hopefully you'll get a gist of it. Until you experience for yourself, it's just going to be words, but I'll try. The first thing I want to talk about, which happened to me twice, but I've seen that happening in every single project, is that people have an idea. They code something, and they get to a fully functional system fairly quickly. And then people say, yeah, AI accelerates my work. I can get everything that I've done before in months, and I could get it in a week. That's a lie. What happens is that you very, very quickly get to something that looks like it's working. But then you spend a tremendous amount of time, usually more time than it would have actually taken you to build a classical system, to get it to a point that it really works. And by really works, I mean does exactly what you want, and not what the LLM engine had thought of at that particular point in time. It's something I refer to as a deceiving start. I've seen people starting startups under the notion of, yeah, it's going to happen very, very quickly because, look, I already have a demo. And I'm kind of smiling at them and said, no, forget about that. The second thing that we've learned is that we can't treat things as a bug. When we're building software, we kind of have something that's working, and then we play with it or do tests, and something happens that is not what we wanted. Usually we go to Jira, Monday, whatever, would open that as a bug, assign it to someone, and then he will fix it. And usually there's a percentage of the project that you allocate to bugs. When it comes to AI software that's driven by an LLM engine or other Gen AI tools, this is not the case. And there are two factors there. The first one is that sometimes the issue is basic into how the model is built, either the model or how we've structured the prompts. You can't solve a problem by putting another patch on it. And a lot of bugs are solved by fixing that particular point in the code that causes a problem. In many, many cases, if you took the prompt in one direction, you can't, for that particular use case, just tilt it the other way around. You need to completely rethink the way the prompts are built, or even the entire architecture of the system is built in the case of agents. Moreover, we found that in many cases, if you just add instructions to the prompt, it loses the attention of what's supposed to happen before that. So it's doing pretty well on 4 use cases, and then not so well on the 5th. If you'll give it more instruction to deal with the 5th, it does worse on the first 4 that actually worked before that. I can talk about the science behind that. It has to do with the attention mechanism, but let's not. Trust me, I've seen systems that people just add more and more and more instructions to the prompt. Pretty soon they break and are able to cope with nothing. Certainty. One of the things that I'm proud of as a senior/old engineer is that I've dealt with a lot of problems in the past. So you can kind of get a problem, imagine a solution to that problem, and if you can imagine the solution, fine, you can kind of estimate the effort, you're going to be 30% more or less, but you're kind of going to be in the ballpark. But it's going to work. It's very, very, very rare that you have a solution in your head, but it's not actually going to work when you get to build a system. That's completely not the case with AI. I've had many, many cases where I had a solution in my head, we've built it, and no, that's not it. Go back to the drawing board. And again, here's another option. Let's test it. We build the system. No, that's not going to work. And you go back, and sometimes you don't even know if it works or not. So we got to a point where we kind of raise it as a theory. It's not even a design. I'm raising a theory that if we'll do this and this and this, it will work. And then you go out and start testing it in the same scientific way that you try to validate theories, rather than designing something and then going ahead and executing it, which is a nightmare when it comes to actually planning, because again, you've raised the theory. I can't give you an estimate of when the project is going to end because I don't know if it's going to work or not. So crossing your fingers as a way of planning is different. Definitely not something that I was used to. Something that's also very, very, very deceiving. I've seen a lot of projects start with something, usually kind of a happy path, and they show that it works. It happened to me with the template injection. It definitely happens to everyone that starts working with conversational assistants. You kind of have a picture in your head of what's supposed to work. You write the prompt, and you go to the LLM, and it actually does what you intended. That's a lie. We need to remember 2 things. The first thing is that behind AI is a statistical model. Even with the same input, sometimes it will produce different results. And God forbid, if the user puts different punctuation in the sentence, it can throw the model to a completely different direction. Not only that, we're used to thinking that if we got the basic scenarios, the pillars of the software working correctly, then the rest of it are just kinks that we're going to iron out. That is not the case. Usually when we see a couple of happy scenarios, it's because we've created the prompts with those scenarios in hand. But then when we're actually going to face production traffic and things are going to look different in terms of the user behavior, the system could behave completely different than what we had in mind. I'm saying this because in a lot of cases I'm seeing people say, I've done this and this and this, and it's working. You need to prove that it's working. And proving that it's working is one of the data science tools and methodologies that I've talked about before, that engineers need to learn how to do. Another point that I found interesting, especially in conversational interfaces, is that we're very used to thinking of a structured UX. In a structured UX, so you kind of have a screen in the business manager. There is a certain amount of buttons on that screen. And when you click on a button, you'll go to another screen. That screen has a certain amount of buttons or text areas to it. And you can kind of create a very deterministic flow of what will happen if the user will do this and this and this. And furthermore, you can push him towards that. You can create a good UX that will get the user to click on the button that you actually want him to click at the right time. And now you get to a conversation. So I've actually seen a production agent that we've deployed where the first question of the LLM was, tell me a little bit about your business so I can help you with the domain. The conversation peered towards the user saying that he's a young child, he doesn't have money, and he wants a free account at Wix because of that. So you can't control the conversation. You need to start thinking differently about how you manage the flow of the product. And because of that, I think we need to rethink what is a product and what is UX. We can't do tractors in the same way that we've done before. Results are subjective. We're all used to green or red tests. It's fun, right? What happens when we actually see a result? And that result is text generated by the AI or a decision made by AI. It doesn't have to be text. I've been to a fun conversation with a content writer on the template injection where we had a scenario in which we showed the results and the content writer said it's horrible. It's really bad content. I said, what are you talking about? It's fine. Look, it's correct. It's to the point. It's very nice. No. It's terrible. It has reputation. It's not engaging enough. A bunch of criterias. We went back and refactored the prompt twice, completely changed the entire system, and now we got different responses. I'm testing it with myself, so I'm saying, oh God, it's horrible. It's just cheesy, and no user is going to like it. I'm showing to the content manager, wow, this is great. This is exactly what I want. This is how we should go to production. Can I say that she is right? Am I right? No one knows. It's completely subjective, and the only opinion we actually care about is the user. So we need to put it in front of users and actually see what they think. Evaluation. There's going to be a great talk by Ola and Olga later on. I recommend that you'll go to that one as well, because evaluation is a nightmare. First of all, because a lot of the responses that we get are not something that can deterministically be said, it's either that or not. In a test, you can say, I've called an API, I got back a result. If the result is different than this thing, then the test fails. But when it comes to text, okay, so I got back a result. The result is text. Is the text good? I don't know. Is the content writer going to say that it's not engaging enough? I don't know. The text is supposed to reply to a question. Does it actually reply to the question? Does it invent stuff? We've given it some content from our Kirby articles. Did it read it correctly? Is the answer grounded enough in the information that was in the Kirby articles, or did the LLM just made something up? And it does that quite a bit. How do you validate that? When it comes to hallucinations, for example, you actually need to read the KB article or be a subject matter expert in order to say this is a good answer or not. And even with those, the subjective part comes into play. And when we give two different people from the same company to say if it's good or bad, they say opposite things. So I've done something, I've made a change in my prompt, and I want to test it. Is it good? If you figure out how to do proper evaluation, let me know. Let's talk about changing roles. In the past, there was a very structured way of building software. You kind of expected the product manager to work on the requirements, talk to the customer, bring back the information, do prioritization, and so forth. The UX helped by building the tractors, the flow of the product, and then eventually the engineers took it and built a damn thing. The tech writer kind of put the final touch by creating the documentation so users will know how to do that. I've been to projects where it's completely upside down. And again, the agent platform, I think, is a manifestation of that, because we basically built it so that the main persona building the product is actually the product manager. We're letting the product manager sit in front of the interface, use English as a programming language, and with that, he builds the assistants that are then deployed into production. Theoretically, he doesn't even need the engineer, but obviously that's not true in most cases. The UX person, as we said before, it no longer builds the exact screen and how to push the user. Now he needs to start thinking about the words that will be used in order to give the user the indications of what he should do next. So all of a sudden, the UX sits next to the product manager who's actually building the assistant. The engineer is there usually for setup, building tools, doing integration, putting the content into the business manager. But obviously, the engineers are doing other stuff now rather than just coding it. The tech writers go over the prompts. Instead of in front of the users, they take the prompts written by the product manager and make them better. Because now the person that needs to understand the text is the AI. But he is subject to the same principles the tech writers know how to do. So the sudden tech writers are involved in prompt writing. And now there's the whole data scientist persona. As I said, at the time of the shift, the group of data scientists at Wix figured out that our skills are needed elsewhere. It's not just building models, it's by helping all the groups apply the technology. So now you have data scientists involved in many of the major projects, and which is something that we've not seen before. So what is the role of the data scientists in that group? We're still figuring that out. We don't know the answer. A lot of roles are going to change, that's obvious. How exactly is the composition of the future team is going to look like? We're still figuring that out. Tests, oh God. When you write a unit test, it's easy. You assume that you talk to something. That something, given a certain input, will always give you that output. So it's very, very easy to write a mock. And therefore, most of our tests are unit tests that rely on mocks. But when one of these components is an LLM, the input is text, and then it's going to respond with whatever it wants. You're going to ask it for a JSON, it's going to respond with text, it's going to ask for a follow-up question. You can't mock it because you don't know what it's going to do. There isn't a clear contract of, given this input, this is the output that you're going to get. So we actually found ourselves really stuck when writing tests for the code that we've done, even if that code is simply taking the output, parsing it as JSON, and move with it for the rest of the system. We've actually had cases where we've built tests that are not E2E tests that do call an LLM in CI. It sounded horrible to us at the beginning, but we really found no other way to do that. And we're very painfully aware of the costs of running tests now. Product monitoring is obviously a grave extension of the problem I mentioned with evaluation. If you can barely tell if what you're doing is right when you're testing it against your predefined questions, how the hell are you going to know if it's doing what it's supposed to do when confronted with actual user traffic and their own text? A user can take the conversation wherever he wants. Was he happy with the conversation? Had the product accomplished what it's supposed to? Did it fail? And fail is not going to be an error. As far as we're concerned, a failure could be the LLM responded with text and returned to the user, but from the user perspective, the system failed. But we're not going to see it because there's one text which is good and another text which is bad. How do we make the distinction between the two of them? We're looking at solutions that can actually help us get traces of information production. Most of the evaluation is done by AI, which is tricky because you need to make sure that the AI evaluating the AI is good, so you need to evaluate the evaluator. And things get really complex from that point on. We still don't have full coverage of production monitoring around AI systems. And finally, I think there's a bunch of other considerations that we as engineers building these systems need to start taking into account. Cost is obvious. AI is tremendously expensive. We don't want to just bombard things. It's very easy to just go with the most expensive model, but things ramp up in cost very, very quickly. So now, all of a sudden, you need to start balancing, not just cutting a little corners in polishing costs, but, wow, I need to redesign the system around a weaker model because I can't afford the costs of the stronger model. I have too much traffic. And usually when you switch to a weaker model, you kind of change your entire architecture. We've done that at least twice in the project I'm involved with. Obviously, you need to balance quality. The more quality you want, the more calls you'll make. And I can assure you that given unlimited budget and unlimited latency, we can build systems that make almost zero mistakes and do exactly what the user wants. But we can't afford that luxury. If in the conversation interface, we can't just keep calling more and more and more prompts to validate and revalidate and redo, because it's expensive and we need to give the user a response at some reasonable time. And I found myself dealing with these concerns, well, in the past, okay, fine, we need to make it a little more efficient. Don't make it, n by the power of 2 complexity, let's try to lower it to O(n), and now we need to think about something that's completely different. Latency. It's perfectly legitimate for an LLM to return a REST call in 5 seconds. I would have been horrified calling a third-party vendor where the REST call is returned in 5 seconds. But no, that's just reality. And you need to figure out what to do with it. How to wrap the product around that, how to give good user experience around that. Obviously not to fail. I've seen calls at Wix fail simply because they changed a few code together and get to the maximum of 60 seconds of how long it takes to do an RPC call. So these are problems now we need to deal with and start solving. All right, and with that, let me take you a little bit about my summarization of what I've learned, how I see things progressing, and hopefully this will tie things up. So first of all, rest assured, as opposed to what we've been thinking in 2022, it's not a magic, it's not game over. Using AI is actually still pretty hard. It requires a lot of skills from the people sitting in this room using these systems. It is getting easier. In the past, getting a response from an LLM that looked like a JSON, it was a form of an art. You need to really prompt it correctly to put some guardrails around it. You need to validate, retry, blah, blah, blah. Today, you can just tell it, return a JSON, and here's the JSON schema, and that's it. So that's an entire skill that I had to learn that now I can unlearn because it's just given as a default. The models are getting stronger. There's more context window, so you don't need to be so stingy about what you give the model. Reasoning is becoming better. So it's getting easier to use AI, but it's definitely not easy, and I don't expect it to become trivial anytime soon. Software is changing. That's a deep one. I think we're already seeing software that relies on AI, and I think agent and conversations are a manifestation of that, but a lot more is going to change. You've seen what's happening in the search realm. Things that we used to have, like I go to Google, I click something, and then I get a website, are no longer happening because the AI just summarizes 10 websites and gives the result. One thing that you'll notice is that now people engage with those websites without actually clicking on the website. So what does it mean for websites? What does it mean for designs? What does it mean for the software that we're building? We keep talking about agents. Right now, we're very focused on agents on the side of the business, but personal agents are coming. That's a definitive thing. It's just a matter of how long. Once we get to that point, mostly the interaction people will have with software will be through their own agent. And if the agent can be dynamic and it can interact with different pieces of software, websites, other vendors, APIs, whatever, for example, he could build a UI ad hoc to the user at real time. So now we need to think differently about the software that we publish because that software needs to go to an agent and not to the user. And same goes on our end. Right now we're building deterministic software. We've already started building our software as agents. And I personally believe that we'll very, very quickly start seeing a world where two agents talk to each other, the customer agent and the agent of the business and, of course, the software. If you ask me what it actually means for the software that we're building, I don't know yet. We'll need to figure it out. I'm seeing the role of the engineer evolving. I think that's kind of the key point that I want to check you through it. But maybe we'll look at the past. My late father-in-law was a software engineer. He started with the Weizmann Institute. And he told me a story about a project, a paid project that he had where he needed to help a company sort the content of their warehouse, so we actually built them a sort algorithm using punch cards. Now, today, I would imagine that everyone in this room, when he wants to do sort, he will do something, 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 that sort. We don't actually worry about that. It's not a consideration anymore. So, does it mean that building software became easier? Vice versa, it actually became harder. Now we need to add more requirements because the easy stuff got solved. And now it's actually harder to build software. If in the past it was a very structured process, and this is why it's called engineering, from building bridges, today we need to see engineers that are creative. In order to inspire that creative process, we have agile methodology of how to work in a team, how to do collaborative projects. And all of these requirements were added to what it means to be a software engineer. And this is why every single one of the people in this room is probably more advanced than the software engineers of 20, 30 years ago, because you need more skills in order to solve the current problems that we're facing. And I think we're going to see another step of that. So, to summarize things, we're seeing that the software that we're building is going to change. It's already changing. That's a definitive statement. We just don't know exactly where it's headed. We're going to use different tools. If you're not using AI tools for coding like Copilot, don't use Cursor because we're not to do that at Wix, but you get the gist of it. If you don't, start. There's really no need for you to manually write the boring stuff that we used to write before. Just tell it what you want, get it, and take a look at what it's writing. So use AI. You've seen the fun video by Yaniv for an engineer that actually manages a team of agents, and they're building it for him. This is a realistic future. This is what many, many companies and very heavily budgeted people in the world are actively working on accomplishing. This is not like a dream scenario. This is going to happen. We don't know 2 years, 5 years, but this is happening. So this is where all the changes that you as an engineer will need to start thinking of. In that world, do I need to write the best piece of code? Probably not. But do I need to be able to see something that someone wrote and say if it's good enough? Yes. Do I need to be able to explain things in a very clear, structured way? Yes. These are skills that I've learned as a team lead, not as an engineer. Do I need to solve problems that require more creativity? Yes, because the busy work is just going to be solved by AI. No one's going to need me to do the busy work anymore. I need to start thinking more high level. What about communication? I'm going to need to be more collaborative with other people, with the customer, with teammates, other people who are managing teams of AI. And at the end of the day, we find ourselves being in a world where the skills that are required from us are completely different. But we're able to accomplish a lot more once we master those skills. So I've referenced to being an engineer in the age of intelligence. This is a term coined by Sam Altman. And I think it is something significant. People are starting to look at what's happening right now as the shift of the industrial age. And obviously, the shift to the industrial age has changed everything. If you haven't known the concept of management, what we refer to as a manager today was actually invented by Henry Ford by building the production line, which is part of the foundation of the industrial age. So things that we take them as for granted now were completely alien before that change had happened. And I think we're now really standing at that point in time. If you guys managed to learn something from my lecture, and be very welcome to talk to me afterwards. If you'll be the ones making the change and learning how to adapt to those new reality, you'll thrive. I'm sure several people will not, but that's not you. As long as you learn how to evolve your skills, pick up new stuff, which you should do anyway, but I think it's going to be more significant now, you're going to be fine. Just be aware of it, that things are changing. Don't sleep on it. Thank you very much.